Good afternoon to all. Welcome back to chemistry class. Today we are going to study about remaining two quantum numbers. What are remaining two quantum numbers? Magnetic quantum number and spin quantum number. Magnetic quantum number and spin quantum number. Yesterday we learnt about principal quantum number and azimuthal quantum number. Principal quantum number n. It represents shell. All of you know about that. Shells are energy levels. And azimuthal quantum number L. It represents subshells. Subshells. Whatever subshells are having S, P, D and F. Whatever shells are having K, L, M and N. And so on. So, when an electron revolves around the nucleus, the electron revolves around the nucleus in a circular path. That circular path we called as the orbit or shell. How many orbitals shells are having? K, L, M, N. When n is equal to 1 means K shell, n is equal to 2 means L shell, n is equal to 3 means M shell, n is equal to 4 means N shell. Okay, it is also known as energy level, various energy levels. Okay, within the shells are divided into subshells. The shells are divided into subshells. Okay, what are subshells are having? S, P, D and F. In K subshell divided into S. K shell divided into S subshell. And L shell divided into S and P subshell. And M shell divided into S, P and D subshell. And N shell divided into S, P, D and F subshell. These are about principal quantum number and azimuthal quantum number. Okay, so what about magnetic quantum number? What about magnetic quantum number? The magnetic quantum number, this number divides the subshell into individual orbital. This magnetic quantum number means this number divides the subshell into individual orbitals which holds the electrons. The orbitals holds the electrons. Okay, so the shells are divided into subshell. These subshells are further divided into subshell, otherwise known as orbital. Understood? What about orbital means? What is orbital? Orbital means three-dimensional space in which the probability of finding electrons is maximum. Orbital means three-dimensional space in which the probability of finding electron maximum. That space we called as orbital. Okay, the subshell are divided into subshell. Within the subshells, subshells are having, otherwise known as orbital. Understood? Within the orbitals, electrons are having. Okay, within the orbital, electrons revolve around the nucleus. Understood? So shells, about shells we studied about shells means principal quantum number, subshells, azimuthal quantum number and subshell, and is about magnetic quantum number. Understood? This magnetic quantum number divides the subshell into individual orbital which holds the electrons. There are 2L plus, how much orbitals are having? There are 2L plus 1 orbitals in each subshell. In each subshell, how many orbitals are having? Or how many subshells are having? 2l plus 1 subshells are having. 2l plus 1 subshells are otherwise known as orbitals. Okay. 2l plus 1 means, what are the integral value of L? Integral value of n means 1, 2, 3, 4 and so on. Integral value of L means, integral value of L is starting from 0 to n minus 1. You know, yesterday we studied about clearly. So n minus 1 means when n is equal to 1, n minus 1 is equal to 0. Okay, so integral value of L means 0, 1, 2, 3, 4 and so on. Okay, here the magnetic quantum number represents the orbital or subshell. How many subshells are having in each shell? Each shell, how many each subshell, whatever orbitals are having. That is 2l plus 1 orbitals are having in each subshell. Okay, so 2l plus 1 means when n is equal to, when L is equal to 0, integral value of 0, value of 0 is starting from 0, 1, 2, 3. Understood? So when L is equal to 1 means how much orbitals are present? L is equal to 0 means how much orbitals are present in the subshell? 2l plus 1 formula. So we are applying 2 into L means L is equal to 0 plus 1 is equal to 2 into 0, 0, 0 plus 1, 1. Okay, understood? So when L is equal to 0 means, which indicate which subshell? S subshell. L is equal to 1 means P subshell. And L is equal to 2 means D subshell. L is equal to 3 means F subshell. Already yesterday we learned clearly about that. Okay, so when L is equal to 0 means S subshell. Within the S subshell, how many orbitals are having? Only one orbitals are having. Okay, so that we call as S orbital. S orbital. The S subshell, how many orbitals are having? Only one orbitals are having. That orbital we call as S orbital. Understood? When L is equal to 1, L is equal to 1, which is the formula? 2L plus 1. So 2 into 1 plus 1 is equal to 2 into 1, 2, 2 plus 1, 3. When L is equal to 1 means P subshell. These P subshells, how many orbitals are having? 3 orbitals are having. We call this P orbital. That we call as P orbital. So S subshell, how many orbitals are having? Only one orbital. We call as S orbital. And P subshell, how many orbitals are having? 3 orbitals are having. We call as P orbital. And then what about L is equal to 2? L is equal to 2 means we call as D subshell. In this D subshell, how many subshells or how many orbitals are having? 2 into L value 2 plus 1 is equal to 2 into 2, 4 and plus 1, 5. 5 orbitals. So D subshell, how many orbitals are having? 5 orbitals are having. Understood? And then when L is equal to 3. L is equal to 3 means which subshell? F subshell. In this F subshell, what is the formula we are using? 2L plus 1. 2 into L value 3 plus 1 is equal to 2 3 is 6 plus 1 7 orbitals are having. In F subshell, we called as F orbital. So orbital, how much F orbital? 7 F orbital having. So D orbital, 5 D orbitals are having. And P orbital, how much? 3 D orbitals are having. S orbital, only 1 orbitals having in S orbital. Understood clearly? Okay, so shell, the electrons revolving around the nucleus in circular path we called as shell. Each shell are divided into subshells, and each subshell are also divided into subshells. We called as orbital. Understood? About orbital, now we are going to study. Understood? Okay. The magnetic quantum number denoted by letter ML. The magnetic quantum number denoted by letter ML. It takes the integral values. It takes the integral value ranging from minus L to plus L through 0. It takes the integral value ranging from minus L to plus L. Okay, it takes the integral value ranging from minus L to plus L. Magnetic quantum number takes the integral value ranging from minus L to plus L. Okay, so L value, how much? When L is equal to 0, 1, 2, 3 and so on. Okay, so what about the integral value for magnetic quantum number ML? ML means it is ranging from minus L to plus L. Suppose when L is equal to 0, L is equal to 0, what is the integral value of magnetic quantum number for this subshell? It is ranging from minus L to plus L. So L value here 0. So integral value of magnetic quantum number for 0 is equal to 0. L is equal to 0 means 0. Okay, when L is equal to 1, L is equal to 1. What about the integral value of magnetic quantum number? It is ranging from minus L to plus L. So L value here 1. So it is ranging from minus L to plus L through 0. Through 0. So integral value of magnetic quantum number ranging from minus L to plus L through 0. Okay, 0 through 0. So when L is equal to 0, the integral value of magnetic quantum number is 0. When L is equal to 1, L is equal to 1, the integral value of magnetic quantum number means minus L, 0 plus minus 1, 0 plus 1. Understood? Because the integral value ranging from minus L to plus L through 0. Through 0. So when L is equal to 1, what is the integral value? Minus 1, 0 plus 1. Understood? When L is equal to 2, what is the integral value of magnetic quantum number? When L is equal to 2 means, so it is ranging from minus L to plus L through 0. Okay, so when L is equal to 2 means minus L, minus 2, L is equal to 2, so minus 2, minus 1, 0, plus 2, sorry, plus 1 and plus 2. Understood? When L is equal to 3, L is equal to 3. What about the magnetic quantum number? The magnetic quantum number ranging from minus L to plus L through 0. Here L is equal to 3. L value is 3. So it ranging from minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. This is about the integral value of magnetic quantum number. Understood? This is about the first point. And what about the second point? the different values of m for a given L value represent different orientation of orbitals in space. Okay, so it tells about the different orientation, the different value of m for a given L value. This is the given L value. For the given L value, having different orientations of orbitals are having different orientation of orbitals. So for orbital means, for example, -1, 0, +1. This is a p orbital. L is equal to 1 means which orbital? P orbital. So p orbital means -1, 0, +1. So different orientation of orbitals. Understood? Okay, and what about the third point? Third point, the experimental justification for this quantum number provides the Zeeman effect. The experimental, this is about the mathematical expression. The experimental justification for this quantum number provides the Zeeman effect. Zeeman effect. Okay. So Zeeman, it is one of the scientists. He did an experiment to identify the magnetic quantum number. Okay, how he did an experiment? He did an experiment by applying the magnetic field on atom. Magnetic field on atom. When magnetic field is applied on an atom, the spectral line splits. When a light or magnetic light is applied on the atom, the spectral lines split into several lines, several small lines. Okay, from these lines, Zeeman found that the magnetic quantum number. Understood? In physics, you studied about that clearly about the Zeeman effect. Understood? The spectrum lines, spectroscopy, you studied in physics. Okay, understood? So what about third point? The Zeeman effect provides the experimental justification for this quantum number. Understood? And what about the fourth point? The magnitude of the angular momentum is determined by the quantum number L, while its direction is given by the magnetic quantum number. The angular momentum magnitude, the magnitude of angular momentum is determined by the quantum number L. The quantum number L, yesterday we studied about that. One of the formula having, calculate the angular momentum. What is the formula? Root of L into L plus 1 into h by 4 pi. To calculate the magnitude of angular momentum. But here, the magnetic quantum number used to calculate direction of the electrons. Okay. The magnitude of the angular momentum is given by the quantum number L, while its direction is given by magnetic quantum number. Using magnetic quantum number, we have to identify, we can identify the direction of orbital, direction of different orbitals. Understood? Okay. This about magnetic quantum number. So it is denoted by letter ML. It takes the integral values ranging from minus L to plus L through 0. If L is equal to 1, means M is equal to minus 1, 0 and plus 1. So different values of an M for a given L value represent different orientation of orbital in space. Different orientation of orbital in space. The Zeeman effect provides the experimental justification for this quantum number. The magnitude of angular momentum is determined by the quantum number L, while its direction is given by the magnetic quantum number. Understood? I hope all of you understood. And then, secondly, we are going to study about spin quantum number. Spin quantum number. Spin quantum number. The magnetic quantum number represents the orientation of orbital in space. Okay, orientation of orbital in space. But here, spin quantum number, it represents the spin of the electron. Spin of the electron. What do you mean by spin? Spin means spinning or rotating. Okay, the spinning of electrons within the orbit, within the orbital. Okay, the magnetic quantum number represents the orientation of orbital in space, or orientation of orbital in space, in three-dimensional space, how it rotate. Okay, wow, orientation of orbital in space. But spin quantum number, it represents the spinning of electrons within the orbital. How the electrons are spinning, it is explained by the spin quantum number. Understood? It is denoted by the symbol ms. Magnetic quantum number denoted by the symbol ml. The spin quantum number denoted by the symbol ml. Understood? The spin quantum number represents the spin of the electrons and it denoted by the letter ms. We know about the electrons revolve around the nucleus in a circular path. Already we learned. But here, the electrons in an atom revolves not only around the nucleus but also spin about its own axis. The electron not only revolves around the nucleus, the electrons revolves not only around the nucleus but it spins about its own axis. You know, every orbital having two electrons. Each orbital having two electrons. Okay, these two electrons spinning its own axis. Revolves around the nucleus, but not only revolves around the nucleus, but it also spinning or rounds its own axis. Okay, each orbital having two electrons. One, it is the spin up and the other one spin down. Okay, so it we can understood from this, the electrons, it spins in clockwise direction or in anti-clockwise direction. It spins about clockwise, this direction, clockwise direction and anti-clockwise direction. Okay, understood? The spinning of electrons explained by the spin quantum number. Spin quantum number explained by the spinning of electrons within the orbital. Understood? The corresponding to the clockwise and anti-clockwise spinning of the electrons, maximum two values are possible for this quantum number. So this quantum number, maximum values, how much? Two values. What are the values? It is equal to minus half and plus half. Okay. What about the two values? Minus half and plus half. Understood? The spinning of electrons within the orbital is explained by the spin quantum number. Understood? Okay. And now once again, let me repeat all four quantum number. What about first quantum number? Principal quantum number. It denotes the symbol n. Okay, n is equal to whatever integral value of n. 1, 2, 3, 4 and n is equal to 1 means, what is the n means it represents the shell. So n is equal to 1 means it represents K shell, and n is equal to 2 means it represents L shell, and n is equal to 3 means represent M shell, n is equal to 4 means it represents N shell. Okay, and then azimuthal quantum number, it represents L, it denotes the L, and whatever the value of L means n minus 1. Value of L, it is ranging from n minus 1. So n minus 1 means n minus 1, n is, when n is equal to 1 means L value 0. When n is equal to 2 means L value 1. When n is equal to 3 means L value 2. When n is equal to 4 means L value 3. Okay, so each value represents the subshell. Each L value represents about subshell. L is equal to 0 means which subshell? S subshell. L is equal to 1 means which subshell? P subshell. And L is equal to 3 means which subshell? Sorry, 2 means D subshell, 3 means F subshell. Okay, understood? And what about the integral value? Integral value of L. Integral value of L means integral value, it is ranging from 0 to n minus 1. 0 to n minus 1 means 0 to, from the s orbital, the 0 to L minus, when n is equal to 0, 1 means 0. Okay, 0 only. And n is equal to 2 means 0 to n minus 1. N minus 1 means 2 minus 1 is equal to 1. So it is ranging from 0 to 1. And when n is equal to 3 means 0, 1, 2. And when n is equal to 4 means 0, 1, 2 and 3. What about the magnetic quantum number? Magnetic quantum number ranging from minus L to plus L through 0. Minus L to plus L through 0. Okay. So magnetic quantum number M, L, the value when n is equal to, when L is equal to 0. Okay. When L is equal to 0 means it is ranging from minus L to plus L through 0. Here 0 means 0. When L is equal to 1 means minus 1, 0, plus 1. When L is equal to 2 means minus 2, minus 1, 0, plus 1, plus 2. When L is equal to 3 means minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. These all about the values of quantum number. Okay, all of you note it, very, very important. And then today assignment, write the features of magnetic quantum number and spin quantum number. Write the features of magnetic quantum number and spin quantum number. Okay, If you have book, take book, page number 45. Page number 45. Magnetic quantum number ML. First point, it is denoted by the letter ML. It takes integral values ranging from minus L to plus L through 0. That is, if L is equal to 1 means M is equal to minus 1, 0 and plus 1. Second point, different values of M for a given one L value, different values of M for a given L value represent different orientation of orbitals in space. Third point, the Zeeman effect provides the experimental justification for this quantum number. Fourth point, the magnitude of the angular momentum is determined by the quantum number L, while its direction is given by magnetic quantum number. What about the fourth point? You mark. Okay, and about the spin quantum number that represents ms. First point, the spin quantum number represents the spin of the electron and is denoted by the letter ms. Second point, the electron in an atom revolves not only around the nucleus but also spins its own axis. Okay, the electron in an atom revolves not only around the nucleus but also spins about its own axis. The first line fully and second line from about here to here mark. Either about its own axis, either in a clockwise direction or in anti-clockwise direction. Enough. 3 points enough. And third point, corresponding to the clockwise and anti-clockwise spinning of the electron, maximum 2 values are possible for this quantum number. Fourth point, the values of ms is equal to minus half and plus half. Okay. Students, study well. Don't waste your time. This is the precious time to study. Everyday portion study every day and write and send me through WhatsApp number. Okay. Don't forget. Study well. Thank you. Thank you all of you.